Welcome to the Explainer. Have you ever stopped to wonder how your phone gets what you mean when you use a voice command? Or how a search engine just knows what you're looking for? Well, today we're going to pull back the curtain on exactly that. How we take all the messy, chaotic stuff of human language and turn it into something a computer can actually understand and work with. So just look at this paragraph right here. To you and me, it's a speech, right? It's got meaning, it's got context, but to a computer, in its raw form, this is just a jumble. It's a bunch of characters and species and punctuation with no inherent meaning at all. So that's the million-dollar question, isn't it? How do we build a bridge from our messy, subtle language to the super rigid black and white world of a computer? How do we get a machine to find the actual signal in all of that noise? Well, the answer is in this really fascinating field of AI called natural language processing. You'll hear it called NLP for short. And believe me, this is where the magic really starts to happen. Okay, so you can think of NLP as basically teaching computers to be translators between us and them. But before a computer can even dream of understanding what words mean, it has to wade through all the clutter. The very first step, it's got to clean house. And our first tool for this big cleanup job is a technique called stop word removal. It sounds simple, but it's an incredibly powerful first step to just get rid of words that don't really add much meaning to the sentence. These common words, we call them stop words. They're kind of like conversational fluff. Words like are, the, in, for. They're essential for grammar for us humans, but for a computer that's just trying to figure out the main topic of a sentence, they're just noise. They get in the way. And right here, you can see that transformation happening. I mean, look at this. On the left, we've got our original phrase. Then after the code on the slide does its thing, look what we're left with on the right. Cats running faster. All that grammatical fluff is just gone. And the computer is left with the pure, essential meaning of the sentence. Pretty cool, huh? And get this isn't just an English language trick. Oh no, these NLP toolkits, they have stop word lists for tons of languages, everything from Spanish to Arabic. So this is a fundamental first step no matter what language you're working with. So we've cleared out all the obvious clutter. Great, but what if we need to find something really specific, like an email address in a giant document, or a date, or maybe a phone number? For that, we need a tool that's less like a broom and, well, more like a surgical scalpel. And that tool is called regular expressions, or Regex for short. Okay, the best way to think about Regex is like its own special mini language. It's a language designed for one thing and one thing only, finding patterns in text. If you've ever used find and replace in a text editor, imagine that, but on super soldier serum. That's Regex. And it is absolutely essential for all kinds of practical stuff. I mean, we use it to check if an email address is in the right format, to pull all the phone numbers out of a web page, or to clean up messy data. It is the absolute workhorse of data cleaning. So let's look at a super simple pattern to see how this works. See those square brackets? They create a rule that says, hey computer, match any single character that I put inside here. So CC literally means find either a lowercase c or an uppercase c. You follow that with at and boom, the computer can now find both cat and cat. Simple but powerful. All right, so that was a pretty simple start. But the real magic of Regex is when you start combining these rules into more complex patterns. So now let's walk through some real-world examples and see how this actually works in code. We can even tell Regex what not to look for. And it's so clever. If you put a little caret symbol, that's the at, as the very first thing inside the square brackets, it flips the whole meaning. It negates the search. So a pattern like comma, quote, square bracket 0 to 9, doesn't find numbers, no, it finds everything that is not a digit from 0 to 9. Okay, so here is the block of text we're going to use as our little playground. It's got everything, uppercase, lowercase, numbers, and even some special characters. Let's put these new Regex skills of ours to the test. All right, first challenge. Let's find words that have 0 vowels. Now I know that pattern on the screen looks kind of intimidating. Don't worry, let's just break it down. The B at the start and end just means word boundary. It tells the computer to look for whole words. Inside the brackets, we see our little friend, the caret, comma, which means not. And what are we telling it to not find? All the vowels, upper and lowercase, plus that slash, which means any white space. The plus sign at the end just means one or more characters. So, putting it all together, this thing is looking for whole words made up of characters that are not vowels and not spaces. Okay, let's try something a little simpler.
How do we find every single character that is not a lowercase letter? Well, the pattern is just beautiful in its simplicity. NP A die. You've got the N for not and A to Z for that whole range of lowercase letters. When we run this, it's just going to snatch up every capital letter, every number, every space, and every symbol in our text.
And you guessed it, the exact same logic works perfectly for numbers. The pattern, quote, not 0 through 9, tells the computer, find me every single character that is not a digit from 0 through 9, and the result is a nice, clean list of all the letters, symbols, and spaces that were in our text. And here is where it gets seriously powerful, because we can just combine all these rules. Take a look at this pattern. We're telling Regex to find anything that is not a lowercase letter, not an uppercase letter, not a digit, and not a white space character. So what does that actually leave? Just the special characters. The @ symbol, the exclamation point, the parentheses, all isolated in one go. Now, because a lot of these patterns are so common, Regex has some really handy shortcuts. So instead of typing out 0 to 9 every time, you can just type /D. Instead of a bunch of whitespace characters, you just use /S. These little aliases just make writing complex patterns way faster and a whole lot easier to read. So we have these amazing, powerful tools to find pretty much any pattern we can think of. But that leads to a really crucial question. How do we know if our pattern is actually any good? See, in the real world, it's not enough for a pattern to just work sometimes. It's this constant balancing act to make sure it's working right. Whenever we're searching through text, we're basically fighting against two types of errors. On one side, you've got false positives. This is when your search pattern is way too broad. It's like a fishing net with holes that are too big. You wanted to catch apple, but you also caught pineapple. On the other side, you've got false negatives. This is when your net is too restrictive, and an apple you actually wanted to catch slips right through. Maybe your search for apple missed apple with a capital A. And this brings us right to the absolute core goal of tuning any NLP system. We are in this constant push and pull. We want to increase precision. That means getting rid of those false positives so our results are really accurate. And at the same time, we want to increase recall, which means getting rid of false negatives so we don't miss anything important. Getting this balance right, that's the secret sauce. It's what separates a great search engine from a totally useless one. So at the end of the day, tools like stop word removal and regular expressions, they give us this incredible power to find the signals hidden in all the noise of human language. And that leaves us with the most important and maybe the most human question of all. Now that we know how to look, what are the things that are actually worth looking for?